Welcome back to class. If you are a second-year computer science or BCA student preparing for your upcoming placements, your current study roadmap likely requires a total overhaul to remain relevant. This transition represents a shift in how systems resolve information. We are moving away from fetching static pages that are deployed at a scale impacting over 1 billion users. Software engineering is shifting to treat agentic AI as the foundational layer of the internet's infrastructure, replacing the previous model where AI was just an optional feature. Today, we are breaking down the specific technical shifts from the conference. First, Gemini Spark, the anti-gravity ecosystem, and agentic search. This is a reality check. The skills currently prioritized in university curricula are diverging from the systems that companies are actively hiring for in 2026. Aligning your projects with these architectural shifts is essential to demonstrating the technical literacy that modern placement offices are now looking for. Let's define the core problem. Standard university courses usually focus on building basic CRUD applications based on the traditional client-server model. Take a look at this graphic. On the left, we have the old request and response loop. This architecture is inherently synchronous. It stays idle until a human provides an input trigger. Gemini Spark removes that human bottleneck. Notice the continuous server cycle on the right. Spark functions as an autonomous agent designed for long horizon tasks that execute entirely in the background. These loops operate independently of user triggers because they don't run on local hardware. They are hosted on dedicated Google Cloud virtual machines. This software engine is powered by Gemini 3.5 Flash, which was specifically optimized for these continuous background operations. This enables true headless operation. The system can manage multi-step processes without waiting for a UI click or requiring the user's device to stay active. A basic API wrapper project sits dormant until a user interacts with it, whereas these agents are designed for constant, proactive execution. In 2026, a competitive software engineering portfolio must showcase your ability to architect these asynchronous, agent-driven workflows that function without direct human supervision. The new Antigravity SDK allows you to deploy a functioning agent with just a few terminal commands. While this is efficient, this ease of use can create an abstraction trap for junior engineers. If you treat the SDK as a black box and simply plug and play, you miss the underlying mathematical trade-offs and the computational costs of the model you're deploying. System design interviewers will test your understanding of the architecture beneath the agent. If you cannot explain the logic of the system, your application will likely be rejected. A frequent error is failing to distinguish between specific machine learning structures. Look at this diagram. On the left is a sparse node graph for a basic neural network. On the right is a dense, multi-layered computational lattice representing deep learning. In an agentic system, a basic neural network is often used for high-speed, low-compute routing layers to direct simple search queries. This is vastly different from the dense architectural requirements of a multimodal model like Gemini Omni, which must process complex, multi-layered data streams simultaneously. Each of these structures carries unique computational limits and specific deployment risks that you must account for in a production environment. You cannot build effectively for this new web if you ignore the basics. You must master the theoretical math and the system design before you begin deploying agents. To apply this, let's look at how you should structure your next hackathon project. If you are a Python developer, your role is evolving from writing simple application loops to becoming a system orchestrator. You should use the Google Antigravity ecosystem as your primary deployment framework. The Antigravity CLI is designed to deploy these lightweight, headless agents directly from your terminal. This is the target architecture for a modern project, a multi-agent system handling distinct pipeline tasks. We have a scraper feeding an analyzer, which feeds a report generator. Follow the data flow. Agent A autonomously fetches data from external sources and passes a payload to Agent B. This occurs without any manual prompt. Agent B processes that raw data, and Agent C uses that output to generate a finished formatted report. The success of this project depends on its autonomy. The entire pipeline should execute continuously, without the need for local hosting or human intervention. Google's recent shift proves that search is now a 24/7 autonomous process. Your job is to build the infrastructure that these agents live on. Zooming out, we see the global impact. This map illustrates the Agentic Web, a network processing millions of state transitions per second, independent of human users. Relying on web development methodologies from 2023 is no longer a viable path for new graduates entering this market. To stay competitive, you must focus on mastering Python orchestration and the mathematical foundations of machine learning to architect for the systems of 2026. If you want a deep dive technical breakdown of the Antigravity SDK and its implementation in Python, let me know in the comments. Start shifting your system design thinking toward autonomy today, or your projects will be technically obsolete before you graduate. Class dismissed.